Hi folks, we're going to take a look at the Unit 4 Quiz 1 on Trigonometry and Question 4. So here we've got a question where they give us a bunch of information but they don't provide the diagram for me. Okay, so the first thing I need to do is, based on the information given, is to create a diagram so I can more easily work with whatever triangles I'm going to need to work with. So here we have someone who's standing near the edge of a roof of an 80-meter tall building and is facing a taller building. Okay, so what we have here is we have two buildings. Okay, so we have a shorter building that the person is standing on. Okay, so they're at the edge of the building here, and we know that this building is 80 meters tall, and then it's facing a taller building. Okay, so I've got my taller building. Okay, so this again, just take what is being said and translate it into a diagram. So standing at the edge of the roof of an 80-meter tall building and is facing a taller building. So this one has to be higher. So let's see what's happening now. So he measures the angle of elevation from his position to the roof of the opposing building to be 38 degrees. So angle of elevation means looking upwards, and not surprisingly, since he's looking up at the roof of a taller building. Okay, so best way to show that is to draw a line to what he's looking at, and to remember that the angle of elevation is always measured from the horizontal. So this angle here is 38 degrees. And in fact, if I extend this line all the way to the building, we see that we make a right angle triangle. We can assume it's right angled because it's one of those reasonable assumptions we make that buildings go straight up. Okay, now let's take a look at the other piece of information. The angle of depression, so meaning looking downwards to the base of the opposing building, is 51 degrees. So now this person is looking at the base, so we're going to draw a line to represent line of sight. Okay, and the angle of depression will be, again, from the horizontal towards where he's looking, and this here will be 51 degrees. Okay, and then determine the height of the opposing building. Now you notice here they didn't tell us anything about the height of the person. Okay, so when you're solving one of these problems, you have to solve it with the information that you have. So the only information about the height here is the building, so we'll assume that he's measuring these angles right from the top of the building. Okay, so again, let's repeat. We're given the height of one building, we're told the other building is taller, that's why I drew this taller, and remember that the angles of elevation and depression are always measured from the horizontal. Okay, so now I have to find a way to determine the height of this building. So this is where we see that we're going to use the fact that these are right angle triangles. So I have one triangle at the bottom and one triangle at the top, and hopefully you notice that this length of the bottom triangle will just be the same as the height of the building. So I know that this length here is just going to be 80 meters. Okay, so I have more information on the bottom triangle, but in order to find the height, I'm going to have to determine this length here, and then I can add them together. So this is the length I'm looking for. Let's call that x, but I need to work with the bottom triangle. So often in these scenarios, what you want to try to find is the side length that they have in common. Okay, we notice that this side here, the distance between the buildings, is in both the lower triangle and the upper triangle, and we have enough information in the lower triangle to calculate it. So I call this y, and now I look at this angle 51, and I see that I know the opposite side, and I'm looking for the adjacent side. So yet again, as is often the case with these types of questions, I'm going to be using tan. So tan of 51 is equal to the opposite side, 80, divided by the adjacent side, y. Okay, now here we have to be careful because we have the variable in the denominator, so I'm going to have to take a couple of steps to solve this. So first I'm going to multiply it to the other side so I can get it into the numerator. And now I have to isolate the variable that I'm looking for, and here, since tan 51 is being multiplied, I'm going to have to divide it to the other side. Okay, and now I can calculate y. So let's get our calculator here, and let's try to get it so you can see it. So here we've got, what do we have? We have 80 Okay, 80 divided by 10 of 51. Okay, and we've got here 64.78. So now I have more information on this upper triangle. I know this adjacent side to 38, so now I can determine the opposite side. But since I have adjacent and I'm looking for opposite, I can again use tangent. Okay, so here tangent of 38 is equal to the opposite side, which is x, and the adjacent side, which is the one I just found, 64.78. Okay, and this is nice because the variable is already in the numerator, so I just have to multiply this 64.78 to the other side of the equation. So 64.78 times 10 of 38. Okay, and now let's calculate that. So here we have 64.78. It's already on the calculator, so I'll just multiply that by 1038. Okay, and I've got 50.61. Okay, but of course that's not the height of the building. It's just the height of this upper triangle. To find the total height of the building, I'm going to need to add these two values together. So the height is equal to the 80 meters, which I already knew, plus the 50.61, which is the part I just found. And so I have that the height is just equal to 130.61. And don't forget the measure here, which is in meters. Okay, so just to recap this problem here, I use the information given bit by bit to create a diagram, and then I noticed that I was able to solve the problem using two triangles, and as is often the case, we use the info in the triangle with more information to help us find information about a second triangle. Okay, that's it for now.